Hello, today we are considering the structure of the atom, taking into account the concept of energy levels and energy sublevels. To begin with, let us remind you that energy levels are conditional orbits in which electrons are placed around the nucleus. In a sense, they are the floors that are in any residential building on which electrons are placed. It's a kind of allegory called the Albar principle, and on each energy level is placed a certain number of electrons, which is called in this case sublevels, and is distributed on each sublevel a strictly certain number of electrons too. Let's start here. The energy sublevels are denoted by the letters S, P, D, and F. Accordingly, there are further letters, but so far there are no such electrons in the atom. Now, what is the maximum number of electrons that can reside? There are 2 electrons per S sublevel. This is recorded with the notation S2. On the P sublevels, 6. This is written PV. On D, 10. This would be written D to the degree of 10. And F is 14, which is written down like this. Now, accordingly, there is a certain number of electrons at each energy level. At the first level, which is denoted by the principal quantum number 1, or as the letter K, there are only 2 electrons. And these 2 electrons will be the S electrons and will fill in the first level S sublevels. For example, the element hydrogen and helium will have this distribution then in the second level. The number of maximum electrons is 8, and therefore here 2 S sublevels are filled, and then 2 P sublevels are filled. The S sublevel is filled by beryllium and lithium, and the P sublevel is filled by boron to neon. The third level is the M level, denoted by the letter. The maximum number of electrons must be 18 electrons. But this is how the structure of the atom is arranged, that the third level can distribute electrons maximum in the third period is still 8. So I'll write it down like this, 8 electrons in the third period. And in general, the third period should consist of 3 S's, 3 P's, and there's also a vacancy here for 3 D's. The fourth level is labeled N. It can have a maximum of 32 electrons, but in fact in the fourth period, if you look, there are only 18 elements distributed there. That is, in fact, only 18 of the 32 are filled, but the fourth level consists of 4 S's, 4 P's, then comes 4 D's, and here 4 F's should be filled. This seemingly correct sequence of filling electrons should be perfectly fulfilled for the atom, but this is not the case. In reality, the series of electron distribution in an atom is as follows. The first one S sublevel is filled because energetically it's advantageous to fill the S electrons. Then there's 2 S's, then there's 2 P's. Then comes 3 S's, then comes 3 P's, and it would seem that after 3 P's, it would be a good time to fill 3 D's under the level. But it doesn't happen. There is an explanation for this from the perspective of quantum numbers, which we will talk about in the next lesson. So the next step is to fill in 4 S's, then it's 3 D's, then it's 4 P's. The next one is filled with 5 S's, and notice in the fourth level there are 4 D's and 4 F's not filled yet. This is the structure of elements, i.e., this is how complicated the table is organized. After the 5 S's comes the 4 D's. followed by 5 p's. The 6th period and the 7th period are the most difficult in the periodic table. They have 6 S's filled in, then it's the turn to 4 F's. These elements are placed at the bottom. The periodic table is called the lanthanides. Then comes the filling of 5 D's, followed by 6 P's, while in the 7th period comes 7 S's, again followed by 5 F's. These elements are called actinoids. Lanthanoids are usually designated with 1 asterisk and actinoids with 2 asterisks in the periodic table, but they are located as a rule under the 7th period in the half-long version of the table, and only in the long version they are placed in their places in the 6th and 7th periods. Then comes the filling in of 6 D's and 7 P's. This is how the electrons in the atom are filled in for the chemical elements of the table. Knowing this sequence, we can allocate for any chemical element the electrons in its atom. But for example, let's take the element iron. It has 26 electrons, and these 26 electrons are distributed as follows. Let's write down the electron configuration. It will look like this. I'm going to go strictly down this row. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then 3d6. What is last in the entry, in this case for iron D, indicates that it is a D chemical element. Another entry like this is called the full electron configuration. It's easy enough to check. You can add the upper degrees to each other and you get the number 26 for this chemical element. That's the kind of check that exists. But sometimes, in order not to describe very long, for chemical elements it is customary to do so. Here's up to 3p6. This is the element that is argon. That is this record of square bracket of argon means that this record corresponds to the element argon. And then further write down what is the characteristic for the element iron. 4s2 and 3d6. So this entry is called the short entry for this chemical element. But let's do some more for bromine. Our bromine has the number 35 and it has a full configuration would be 1s2, 2s2, 2p6, 3s2, 3p6. As we can see, in the beginning goes the same way as iron. Then comes 4s2s, 3d10, and 4p5. Thus, we can write down this entry and also shorter. That would be argon. That's what this entry is for argon. And on top of argon are 4s2, 3d10, 4p5. Since in the last entry goes p, we can say that bromine is a p chemical element and is therefore located in the family in the block called p elements. So that you can make such an entry for any chemical element in the Mendeleev table, regardless of its order of number, this series is very important. It should be memorized. Then you will have an idea of how the electrons are distributed for any chemical element. Well, of course, we have elements which can also observe peculiarities, for example, such a concept as a failure of electrons. We're going to talk about that as well. But the absolute majority of chemical elements distribute their electrons strictly according to this series, so it should be memorized, of course. Well, and the general pattern, what electrons, what levels and sublevels there are for elements, I think that now you will also understand. Goodbye.